Okay, this is Introduction to Computational Statistics with R Stats 102A. My name is Miles Chen. I'll be your teacher this quarter. I'm going to move this so you guys can see me over there. Thank you. I think it'll be a great course. Of course, I'm biased, but I do think you'll have a lot of fun. When I was learning R, I had a lot of fun, and I'm hoping to make learning R and well, you guys should have already learned some R in Stats 20, but you'll learn some, a little bit more in-depth stuff, and then we'll do some interesting things with statistics. Okay, so I guess I should have said this. All right, my name is Miles Chen. This is my email address. Sometimes I'll respond and it'll say mileschen@gmail.com, and that's also me. Either of these addresses will reach me. I think you guys are all familiar with CCLE. That's the course management site. My office is in MS 8105. This is when I'll have office hours. All of this I think is posted online, at least in the syllabus. So. And if you're in the if you're a statistics major and you don't know where 8105 is, then you should acquaint yourself. But it's 8th floor of the Math Sciences building. But if you're new here, the Math Sciences building is connected to Bolter Hall, and it can get confusing because it's connected only on like the 7th floor and the 5th floor, but other floors it's not. So, but anyway, okay. Is there not enough seats for everybody? I see people sitting on the floor. There's like a few. This is okay. And then there's a seat up here. And all right, I just don't want you guys sitting on the floor. We can't have people sitting on the floor at the greatest school on earth. So okay, all right. My commitment to you, forgive me for this cheesy part, but here we go. All right, so it says you are the paying customer. It's true, and it's my goal that you are completely satisfied with the course and the teaching I provide to you, and I hope to receive very high reviews from you at the end of the quarter. So that's like our contract, right? I'll do my best for you guys, and then if you liked it, you're gonna give me a high review. This is my second year as a lecturer. This is like my dream job, by the way. I'm like here at UCLA teaching statistics. I love statistics, I love teaching, and I love UCLA, so it doesn't get any better than that. But it's only my second year, and so your student evaluations are very important for the advancement of my, or keeping of my job, really. So anyway. But I think I do a good job. I hope you enjoy it, and so I just ask that in return, you do your learning and you'll give me a review. So here, my job is to educate you to learn the skills and methods for data analysis. And in our class, we're doing computational statistics, and I already said all of this that I love my job. Okay. And if you've chosen to major in statistics, I hope you'll be convinced that it's a good choice. And maybe you aren't a statistics major, but after this class you'll be like, I should major in statistics, and say, I sent you this way. All right. Okay, and so my expectations, if you're not happy, let me know. I don't want you guys to just grumble quietly and then give me a bad review at the end. I also want you guys to put forth a good faith effort to learn the topics covered in the course. Some of these things will be challenging. I expect you guys to work through the challenge, okay? I don't know if you guys are familiar with the growth mindset. Have you guys heard of that? Okay, so there's, I forget what the other one is. But basically, there's kind of two circles of thought as far as how people learn, and one is like, I'm a math person, so I'm good at math and I'm gonna do well, and then, or like, or I'm not a math person, so I'm not gonna pursue math, or something like that. And then there's the growth mindset, which is basically like, if I challenge myself, I can learn anything. And it sounds cheesy, but it turns out that there is a lot of truth to this growth mindset. Maybe I'll link a few of these TED Talks to you on CCLE. But anyway, the idea is some of this stuff that I cover is going to feel hard. Maybe it's like your first time seeing this, or maybe it's like your 10th time seeing it, but it still doesn't make sense to you. Keep at it. You don't get stronger at the gym by watching other people work out. You have to work out yourself. Okay, and so when you're doing the exercises on the computer, I encourage you guys to help each other during the homework, but make sure you are working yourself as well. Okay. Again, if you go to the gym and you have someone else lift the weights for you, you're not going to get any stronger. Okay. So anyway, that's what I expect from you guys to work. Again, you're allowed to collaborate on the homework, but you're expected to do your own work, and I expect you guys to try to learn. So, okay. Anyway, let's get started, is what the slide says. All right. And what is this class about? So, you guys have already taken Stats 20. At least that's the assumption. Anyone here not taken Stats 20? Okay, just a few of you. But those of you who haven't taken Stats 20, I'm assuming you're at least somewhat familiar with R already? Okay, so then we're in good shape, okay? Okay, so anyway, I'm assuming a basic understanding of R. This is computational statistics, and so I'm going to just talk about what statistics is first, and then we'll talk about maybe what computational statistics is. Okay, so statistics. So why do we study statistics? Why did you choose to major in statistics or minor in statistics? I argue that statistics allows us to gain a better understanding of the world. This could probably be said about almost any subject that you were to take. So, biology, you study biology, it helps you understand the world. You take history, it helps you understand the world. Specifically, statistics allows us to take data and then make meaningful conclusions from it, right? We're living at a time where there's tons of data being generated. Every day you walk around and you are generating tons of data just by carrying around a cell phone that's constantly pinging towers and telling people your location. Anything that you do on it is recorded. You go on Instagram and they say like, oh, you were browsing on Google or Facebook earlier, and now I'm going to show you these advertisements that are strangely targeted to you and you're just like, oh, okay. Anyway, so we're generating tons of data and we want to do something interesting with it, and that's where statistics comes in, okay? And so the question that we're always asking is, what does this data tell me about the world? On your phone, it's what does this data tell me about the world, and that what can I sell to you? And so, in your intro stats class, you learned how to describe and summarize data. Okay, it's very important that rather than having all of this information, we can kind of boil it down to a few summary numbers that still gives us an idea of what the data look like without us needing to know every single data point, okay? And then when we do statistical inference, we look at the results and we say, could the results I have, could that have just been a random fluke? Could it just have been something that happened because of random chance? Or does it indicate something interesting going on, right? You should have learned this in when you did hypothesis testing. You're comparing what you have versus what randomness could have produced. Okay, so when you took intro stats, it says you learned descriptive statistics and moved on to inferential statistics, and you performed hypothesis tests. And then, so probably in your intro stats class, at least if you took stats 10 here, or if you took AP stats in high school or something like that, you would have covered confidence intervals and hypothesis testing. Maybe you covered a few other tests like chi-squared tests or things like that. Those things rely on the central limit theorem. Okay, the central limit theorem says when you take a bunch of things, the sample mean will follow a normal distribution, right? And because it follows the normal distribution, or when you adjust it, the t-distribution, we can make conclusions based on that mathematical theory. Okay, and so if you're taking 100B, some of you guys are in this exact same classroom like just 10 minutes ago because of you're taking Professor Christou's 100B class. You're gonna learn the central limit theorem and you're gonna prove it and all of that. Okay, in your intro stats class, you probably did not have to prove the central limit theorem, but rather it was just like, here's this thing, it works, and therefore all of this other stuff works. Okay, and that's also fine. Okay, but if you're majoring in stats, you'll have to prove it, right? Okay, and so when you make a conclusion at the end of a hypothesis test, you're essentially saying something along the lines of, the laws of probability tell me that if the population has a mean of 10, so if your null hypothesis is that the mean of the population is 10, then samples chosen randomly from the population should have a mean close to 10, right? Central limit theorem. Okay, and if, let's say, you draw a sample and it has a mean of 11.3, okay, and so according to the central limit theorem, and the amount of variance that you observe in your sample, maybe that says there is a very low probability or a very small p-value that a random sample has a mean of 11.3. Okay, and that means at the end you conclude that I do not believe that my randomly selected sample comes from a population with a mean of 10. Okay, so I'm hoping all of this logic and reasoning sounds very familiar to you guys from your intro stats course. Yeah? Okay. Smile and nod your head. Okay, so there's some kind of similar logic as far as making conclusions go. Okay. All right, and so all of those things, that's what we call the kind of an analytic approach. All right, and in that case, the null hypothesis being that the mean or the population has a mean of 10 would be a very, very simple data generating model. Okay, and we are assuming a population with a mean of 10 to generate our model. And our model of reality is that we can test the belief that the data we have is generated by a population with a mean of 10, and then the model says that the sample means should come from a normal distribution, and we analyze it that way. Sometimes when you create a model, or you have a model in mind, or maybe you can't even think of the model, the math can get really complicated or even impossible to solve. Okay, maybe you don't want to put any kind of assumptions on the population or things like that. Okay, and so sometimes in these cases, you do computationally intensive methods, okay, such as simulations and resampling to make inferences about the parameters. Have you guys done any kind of resampling tests or anything like that? No? Okay, good. So that will be something new that you will learn in this course. Okay, and so sometimes we can't answer things using the central limit theorem, or we can't answer things in this analytic approach, and so we're going to do computationally intensive methods. Okay, so it says, so here's kind of this general idea of what computational statistics is. It says, computational statistics is a broad field in which we employ the use of the computer and computationally intensive methods to answer our statistical questions. Okay, computational statistics is not simply doing statistics with a computer. Okay, so it's not that we take data and we type in into our t.test, sample 1, sample 2, and it says, oh, p-value 0.005 or something. Okay, that's not computational statistics. That's just plain old t-test using R. And so that's not what we're doing. We're going to get into this realm of computational statistics. Okay. All right, and so this course can be thematically split into two parts. One will be learning the tools, in this case particularly R and its packages, okay? And then the second part will be methods of computational statistics, okay? Or at least some introductory methods, all right? And then I said, this is kind of like woodshop class. Did anyone ever take like wood shop or metal shop in high school? No, right? You guys, oh, some of you did, right? It's like, this is the demographic where you took computer networking or something, right? So, like the first 2 weeks of wood shop classes, like all safety, right? Like don't cut your fingers off. And then it's like, okay, this is how you use the saw and things like that. And then once you learn how to use these different tools, then it's like, okay, now you can make a tree house or something. Something like that, right? Okay. So as far as tools go, we'll cover R Studio, and then R Markdown, and then just programming functions and all of that. We'll start looking at packages like tidy and dplyr. These are packages developed by Hadley Wickham, also known as the tidyverse. Have you guys heard of that term before? The tidyverse? Okay, some of you nodding your head, some of you shaking your head no. So R is great, okay? And part of the thing that makes R great is that you can add on all of these packages, okay? You don't have to reinvent the wheel to accomplish a task that many other people have wanted to accomplish. And so there's kind of this set of packages that this really excellent programmer has created, and these packages are collectively known as the tidyverse, okay? Like the universe, but tidy, because that's one of his packages, or the way he describes how data should be stored. Okay, we'll look at some web scraping and even data visualization with a ggplot2, which is also part of the tidyverse. Okay, so we have that. Okay, and as far as computational statistics goes, we'll cover floating point arithmetic, maybe like a lecture on that. Some numerical methods, maybe one of the most basics being root finding. Okay, we'll cover some very simple optimization. Okay, optimization is this big field. We're going to just cover some very basic methods of optimization, okay? And then we'll look at simulation, and then we'll also look at randomization tests and bootstrap tests, okay? And so this is kind of what we're going to cover as far as computational statistics go. It's a big field, and I know, some of you guys are itching to learn, machine learning and all of these kind of these hot topics and things like that, and I think those topics will probably be covered in the later courses. In the beginning, I think we should kind of start here, and I think it's a good place to start. But and there's nothing stopping you from reading stuff online and finding other books and kind of teaching yourself also. Okay, a lot of learning, especially as far as computer programming goes, a lot of it is going to be partially self-taught, driven by what you want to learn and how badly and how quickly you want to learn it, okay? As in our classes, there's only so much time that we have, and we do have to cover this statistical component too. So, okay, and so we'll get started with some R Markdown. Are you guys? Yes.
How about the grading scheme?
The grading scheme. Okay, I guess I should talk about our syllabus. Here we go. Okay, let's zoom in here. Okay. That's the description. This is all of this. Okay. Oh yeah. Okay. So we'll talk about books. So for this class, I was able to find pretty much all of the content I wanted on textbooks that are available for free for you guys, okay? So that's, some of the other classes, like I couldn't find it all in free textbooks, and I'm gonna have to make students buy buy books. How terrible. But okay, so Advanced R. This is by Hadley Wickham. This is an excellent book. There are a couple places you can. What is this? You can get it. One is CRCnet base. You click this, and it's opening the Microsoft browser here. And it's right here. You can download it as long as you're connected to the UCLA network. You can download these chapters. This is in PDF form. Hadley also kind of pretty much maintains it. You do Advanced R, and this is like his. This is like a HTML version of the same stuff. Okay. So you can get it as long as you're connected to the UCLA network. You might, if you go home and you're not on campus housing or something like that, download the VPN and log in. Okay, so I'm assuming you guys can know how to use the VPN. So, and if you don't, go to Google and type in UCLA VPN and then follow the instructions. Right? Okay. Okay, and then. So anyway, you know, if you want to teach yourself a bunch of stuff, you have UCLA has all these subscriptions to these digital libraries, which are excellent. One of them is Safari Books Online. You just go to proquest.safaribooksonline.com. Okay, and this has like almost the entire O'Reilly library. So you want to learn like. You know, so this class is all R, but Python is a good language to learn also. And if you want to learn Python, you just come here and type in Python, and all of these books on learning Python pop up. Okay, so O'Reilly is the O'Reilly books are very practical. There's not a whole lot of theory in the O'Reilly books, but it'll teach you like coding away. Okay. And then, you know, Springer Link is also another thing, and then there's CRCnet base. So anyway, you can, most of these textbooks, so at least for this class, the textbooks that we're going to be using are all available to you for free. If, you know, of course they're going to be digital versions of the textbook. So if you insist on having a hardcover or, you know, paperback version or whatever, then you'll have to spend money, and you just go to whatever store. I know the bookstore has like a textbook listed for this class, and I think that's just like an artifact from past iterations of this course. You don't need that textbook, okay? If you bought it, you know, take it back to the bookstore and return it, okay? You don't need it. Yes?
Is there like a main textbook?
Is there a main textbook?
Yeah, one that we could like read the chapter of like every week or something like that.
No. so the way it works is, you know, I'm basically selecting a few chapters out of this book, a few chapters out of this book, and a few chapters out of that book. Okay. I guess the two textbooks that we'll be using the most, at least in the first half of the class, will be the Advanced R book. Okay. We'll cover like the first 6 chapters in Advanced R, and then we'll get also use some. Intro to Scientific Programming and Simulation using R, okay? And this we'll go through several chapters in that book. Yes?
Just one more thing. So what's a good way to prepare for class before we come?
I don't know, like, so come, how do you stay up to date in the class? I would say come to lecture, right? Pay attention. And then, you know, when I assign the homework, work on the homework. I don't know. Is this like a trick question? I don't know. How?
No, it's not. I just like if you want to like read things before class. Like...
Yeah. Okay. So, yeah, I guess I can post the read. So in the homework, I'm gonna have like these are the chapters you should read. I guess I could post the next homework early, and you can kind of get ahead that way. Yeah. So yes, question.
Are you going to upload a video to the YouTube?
Yeah. So I'm recording what's going on the screen, and the words coming out of my mouth, and that I'll post this video to YouTube, assuming there's no glitches. Sometimes things break and it doesn't work. But you know, assuming this works, I'll upload it to YouTube, and you can watch this thing. You can put it on double speed and have it get the lecture content in 25 minutes. Yeah.
I was wondering, like the RStudio and the Linux distributions like different from like the Windows version?
I don't think so. I mean, I don't know. I've used it on Mac and I've used it on PC. I haven't used it on, or I should, Mac and Windows. I haven't used it on Linux, but I assume it's the same. Okay. But I don't know. I would assume it's the same. Okay. So it should all work. Okay. And so yeah. You know. So okay, so advanced R covers kind of R stuff a little bit more from a computer science perspective, and it gets a little bit more into the nitty gritty on you know, how R stores things and all of that, which is important. And then the introduction to scientific programming and simulation using R covers R programming a little bit more from a statistician's or scientist's perspective, in that there's a little bit more talk on how kind of the certain theory stuff should work, and then and whatnot. So this will kind of be our big texts for the first I don't know, 2/3 of the course, and then when we get into bootstrap and randomization methods, we'll be using this textbook. Okay. Okay. So as far as your grading goes, I'm going to have 6 homework assignments, and they're all each worth 10% each, okay? And none of them are dropped, so don't like skip a homework assignment, because that's 10% of your grade, okay? We'll have a midterm exam and a final exam. They're going to be in class, okay? There were some issues with having the take-home exam, and so I've decided to make the exams in class, okay? But the homeworks will be, of course, take home, right? And then we'll have class attendance and Piazza participation. So I might take attendance on just some arbitrary days, okay? And it'll just be traditional roll call, yeah.
Well, yeah, I was gonna ask, like, is there gonna be a sign-in sheet to pass around?
Yeah, I don't know. Probably I'll call out your name and see if you're here, okay? Because you know, 99% of you are honest, okay? Or maybe 95% of you are honest, but some of you, you know, not because you're like malicious or anything, but you want to sign in your friend who's not here, and that defeats the point of taking attendance, right? So and that's just gonna be taken on arbitrary days. I'll send you a invitation to Piazza. I don't know if you've heard of this. It's kind of like it's like an online forum, but for the class, and you can post questions and things, and either I or other students can answer your questions. Okay. So I think so that will be good. Okay. And so I'll be moderating Piazza, and our TAs will also be in there. Okay. Okay. As far as the homework assignments go, I'll post each homework, and you'll do it, and you'll follow the instructions in the homework. The first homework is already up. This first homework assignment is maybe the most dry of the assignments, and I apologize for that. But it's also probably, well, I don't want to say the easiest, but of the 6 homeworks, it'll probably be the easiest one, okay? And this one is kind of like, you're going to read the textbook and you're going to answer questions based on the reading. Whereas the other homeworks, there's going to be a little bit more of a programming component to it, which will be important, okay? But anyway, all of your things will be they'll be posted as R Markdowns, and then you're going to render them as HTML files, and you'll submit your HTML files for grading. Okay. Every now and then I'll have you submit the R file or the actual R Markdown file itself for grading, and that'll be specified in the homework assignment details. Okay. This is the late policy for homework. You get a 10-minute grace period, so the homework might say like it's due at 6 p.m. or whatever at a certain time. Okay, if you submit it within 10 minutes, okay, no penalty, okay, and then starting at 11 minutes, then there's going to be a penalty for being late. Okay, so make sure that the submission went through, right? There's nothing worse than like thinking you've submitted the homework and then you check back 2 hours later and it didn't actually submit. Okay, so set a timer somewhere in your thing and then just make sure that it has actually submitted. All right. But anyway, the late policy is specified here. Basically, if it's late, it's an automatic 10 points off, and then each additional hour is another 5 points. All right. So basically, if it's over whatever 24 hours late, the 0, right? So because that's over. Yeah. Question?
Is there a specific weekday that homework will usually be due on, or?
No, it's kind of. So I kind of look at my schedule for when I would have covered all of the material that you need to complete the homework, and I usually give you like a week after. So it's like if all of the content that you need to answer the homework questions covered by like Wednesday, it'll probably due the following Wednesday or something like that. Okay, so that'll be. That's kind of how it goes. Yes?
Will solutions be posted like the day after the homework? Like
So I probably won't post solutions to the homework. If there's questions that you have about the homework answers, I'm more than happy to answer them during office hours and things like that. But because I anticipate using similar homework assignments or similar questions for future classes, I hesitate to post official answers because I know you talk to other students, and so I hesitate to have the official answer floating around. Okay. Okay. All right. And then academic integrity says, please be honest. All right. And then this is kind of a outline of topics that we'll cover. This is my hope for what we cover. We might have to scratch a topic here or there if we're running out of time. Okay. Okay. Any other questions about how I guess the class logistics or things like that? We're all good? Okay. Then let's come back and okay, so let's talk about R Markdown. Okay, probably many of you are already familiar with R Markdown, but if you're not, this is going to be a brief overview of how it works. Okay, all right. So generally, prior to R Markdown, if you were doing some kind of report or something like that, you would prep your data, do your analysis, then copy and paste your results and graphs and charts into your document. And then you discover that you've made a mistake somewhere in there, or there's something wrong in your data. And then you have to redo everything. You got to copy your results and charts and regenerate them and everything. Okay. So with R Markdown, the R code and analysis is integrated straight into the document. Okay. So if you notice a problem with your data or somewhere in your analysis, basically, you make your updates there, and then because it's everything is carried in the document, you don't have to copy and paste all of your charts and graphs and results. They'll generate again with R Markdown. Okay, and so even this lecture itself is created in R Markdown. This is, I'm using the IO slides presentation, okay? But you know, so this is all of the text that's in this thing. I could just change this if, for whatever reason, you wanted to have the thing presented as a document rather than slides that flip each page. You just change output form into HTML document, and then you click knit HTML, and then ta-da! It's now an HTML document, and it looks like this. Okay. Or for example, if you wanted to change it, there's like another presentation form called Slidey. Okay, and you do Slidey presentation. All right, and then and you knit it, and then you know it has basically a different style, but it's all the same exact content that I had earlier, right? So anyway, we'll go back to our IO slides presentation. Okay. Okay, so so the Markdown files themselves, it's kind of like a play on words because you have HTML, which is hypertext markup language, right? And if you ever open up a HTML file, like you go on a browser and you click you right click view source. Oops. Does that even work here? Okay, you go to view page source, and it's not pleasant to read. Like you can read it, but it's not pleasant, right? Whereas with a R Markdown file, even though it hasn't been rendered or anything like that, you can go through and it looks like a text file that's easy to read. And you know, headlines are kind of indicated with the whatever this symbol is, the hash pound key. And it's made so it's easy to read. Okay, so Markdown was created with readability in mind. Okay, lists look like lists, and table, emphasized text looks like it's emphasized. You put like asterisks or things like around it. Okay, and the downside is you don't have fine control over the exact styling or placement. Okay, but and that's all handled kind of by the templates that go in. Okay. Resources to learn R Markdown. I think the cheat sheet right here, this PDF cheat sheet, this is the best. And it shows you, like, if you type, where's my, no. If you type this is what it's gonna look like. Okay. You want to get an image in, you type all of these things. So that's that. Okay. You get in a YAML, yet another markup language header, and you put that in there. Okay. And generally, you just need a title. You can put in the author and the date, whatever you want. Okay. And then after you've written it up, you render it. Okay. And so it's very simple. Okay, I'm assuming you guys have RStudio already installed. If not, do that. You're gonna have to install R first. So install R, then install RStudio, and then to run R Markdown, you're gonna go to basically right here. Can you guys see that? I don't know. Maybe I have to. Where's my appearance? Magnify everything. I don't know if that's any better. Okay. So you have this little drop down that says new file, and you can create a new R script, or in this case we want a new R Markdown file. And then it gives you some options, right? In this case, you'll want a new document. And you type in right, demo document. All right, and then you can also create PDFs or Word documents if you want. HTML is probably the easiest. If you want PDFs, you need to have MikTech or MacTech installed on your computer, okay? Which you may or may not have already. Yeah, question?
Yeah, I've been having trouble knitting as a PDF because it hasn't been identifying MikTech on my computer. Is there like a common error here, or?
I don't know.
No worries.
Yeah. So, you know, whenever I have problems, I just go to Google and I type in the exact error that I see, and I just almost everybody has experienced a similar error at some point, probably. Okay, so yeah, so okay, so I'll just show you R Markdown, and so anyway, here you click. You got to save it somewhere, right? So let's just we'll just do it here. So you just click the button knit HTML, and then and this is kind of the default document that gets rendered. Actually, let me log into CCLE here. And then so, you know, you can download your first homework assignment. And okay, so it'll say, you know, homework 1, R Markdown template. So we'll click save file. And then, okay, and so this is, you know, this is your first homework assignment. Oh, I might have, oh, I put the wrong, it's actually due October 5th. Okay, let me, I'll fix that, okay? So anyway, you know, this is your first homework assignment, and when you click knit, it's gonna look like this, and then as you go along, you'll just type in your answers, right? So it says, create a vector of the positive odd integers less than 40. Okay, so that's easy. And then it says remove the values greater than 20 and less than 30. Okay, so maybe I'll store this as A and make sure I print A. And then, you know, we want a subset A such that, you know, A is greater than 20 or so. Oh, remove. Okay, so we gotta do this, and then so, you know, I advise against like typing in your code and then immediately knitting to see if it worked, right? So so this looks correct, and then oops, so this is not gonna, what do right, okay, so here, why is this, what did I do? No, this is embarrassing here. Remove the values, let me just see. A greater than 20, this should show me this. And I want to, okay. True. Here, let's, well, anyway, what am I doing here? Okay, I'm on the spot, and now I'm like freaking out here. Okay, but so anyway, you will update your thing here, and then yeah, this is exactly what I want. But then, is the minus not working? This? Maybe I just put the not here. Oh, okay, there we go. All right. So, okay, well, this gets rid of the ones greater than 20, but then we want the ones less than 30. Sorry, yeah, we put the not instead of the minus. Okay, so anyway, you'll work on kind of your conditions to subset this this bit here, and then, you know, as you work on your thing, you're going to click knit, and and then you can see the outputs get shown here. Okay, and then so this first homework assignment, you're just going to kind of answer these questions. You know, it says, you know, what's the difference between null NA and NaN, and you'd write null represents blah blah blah, and you know, whereas NA represents something else, right? Et cetera, et cetera, et cetera. Okay, and then so you'll answer the questions, and then you'll knit it. Okay, the HTML file will be stored somewhere on your computer, and then when you go to for the homework, you'll submit your rendered HTML files. Okay. Are there any questions on how the R Markdown stuff works or anything like that? No. Okay. We'll end there then, and we'll see you guys next week on Monday. I'm thinking it'll be good. Okay.
I'm still not enrolling.